Hi, and welcome to Zuken E3.Series provided by PowerJump Technologies. In this video, we're going to show you how to use Zuken's intelligence to power your vehicle design. So the first thing I'm going to do is just import a DWG, and I'm going to create a block diagram to illustrate where I'm going to put systems and go from there. This is really an overview design stage, and we'll show you how to do it. So I can import a DXF or DWG. I've got one saved already for an armored vehicle personnel carrier, and I'll just open it up. I can scale it, etc. I'm just going to place it as sized and go from there. So you can see here automatically it's actually placed my drawing, so it's made life a bit easier. So I don't have to worry about drawing or anything like that. And I can move it around if need be. Now, a feature of Zuken E3.Series 2018 version allows us to optimize our imagery. So with the DWG, the first thing we'll notice is if I click a particular repetitions, a lot of shapes are made of multiple lines. This obviously takes a lot more data than necessary. So what 2018 does is we have this button down here, which will optimize the drawing and minimize any data in that particular drawing. So it'll convert any polylines and duplicates and multiples into singular, and that way your drawing takes up a lot less room and it's a lot easier and quicker to handle. So the first thing I'm going to do is create some blocks. Now in this case, a block is going to represent a system, be it an ECU or a unit or a particular component. These are pretty dynamic. I can place them as I need to and resize accordingly. I'm just going to place a few in random positions. Now obviously this doesn't necessarily follow any design, but I'll just show you how it can be used. So with this particular one, for example, assuming this is a control unit that I want to use a side view as well as a top view. So what I can do is I can go right click, I can split this block, and it'll let me place that same particular instance in a different position. Let's just expand that out. So you'll see here, this is representing the device designation. This particular part is A1, and it's also got a reference now position, which is sheet 1 E4, and this one has a L3 position, and again it's got that same A1 designation. So what I can do here is I can rename it if I want to, and I'm just going to change that to ECU just for argument's sake. So I can actually go ahead and rename some of this stuff if I need to. I can leave it as it is, or I can change it at a later stage. The next thing I'm going to want to do is to place a connector in these particular blocks. So with these, with the database, there is a dense amount of componentry, but I can search to make life a lot easier. So for example, I want to pick up a mil-spec D38999, and I want to get the FJ series, or variant rather. Okay, so it's brought up these two, and they're the matching plug and socket. And you can see here, if I click on one, it'll actually show me the image and what it actually is. So I can bring it over and place it directly into the block, and it'll actually give me a symbol to represent the 56 pin, the X1 connector, and that's the part number there as well. So these views can all be changed, but nonetheless, I can say I've got in these particular ones, I'll place just a few of them. Now these actually become attached to that particular connector, the block. So if I do move the block over, it does stay with it. So it's pretty dynamic in that sense. At the same time, the designation of the connector does fall inside the relevant block itself. So it's easy to locate, and at a later date you can actually have the function attached to it. So with this particular one, if I wanted to, I could actually just press my connection tool, and then I can connect directly into the socket. Now when doing so, the software actually knows that there is a mating connector, and will actually place for me the mating connector. So I'll just go here and I'll place that one. So you see here automatically it's actually placed this DTS PN connector, and the same thing on the other end. And I can obviously connect multiples to the same circuit like so. So now that I've got here, I've got four sockets. I've got the X5, the X7, X6 and X8. I can go ahead and create a schematic, or I can even create a harness drawing directly from there. So what I might do is I'll just open up a new sheet and I'll create a schematic from that. Now that I have my new sheet open, I'm simply going to replace the same components. I can easily define my schematic symbols in the block diagram view, like I had before, but what I'm going to do is I'm going to do something a bit different. I'll make it quite visible, and then we can define it this way. It's a bit easier, and then the same can be done the other way around. I could have started from this sort of view as a schematic and then built my block or overall topological view based on that. So what I'm going to do is I'm going to close these up. So each A represents the unnamed block, and I've renamed the ECU one here. If I select all, I go right click, place new device view. I'm just going to place one here, one here, one here, and finally the ECU I'll place here. Technically speaking, I can put these at anywhere I want, but nonetheless, I'm just going to place them like this. Next thing I'm going to do is just expand them out so I can actually fit my connector pins individually. The connectors I've decided to use, they're I believe a 56 pin, so they're pretty dense, but nonetheless we'll place them up and we'll go from there. And these can be moved pretty freely, so once I do put a connector in it, it's pretty easy to move things around, so it's pretty flexible. So if I expand my A2, for example, I can get this connector. I can place a new device view again. The standard mill symbols are those blocks, but what I'm going to do is just I can actually do a different view if need be, but what I'm going to do just to make life a bit more clearer, I'm going to change and I'm going to use one of these socket symbols to represent it. That way we can clearly see which one's which, and considering the 56 is probably a little bit clearer. All these symbols are in the database. They can actually be changed pretty easily as well. So I'm just going to place them like so. You placed them on the wrong side, so what I'm going to do now is I'm just going to flip it over the y-axis, so that's okay. So you can see here, if I zoom in, it's got my 56 pin and it's got the designation of them. So with these, most of the mill connectors, you should probably already know, rather than numbers, they use the alphas. So you've got A to Z, then AA to LL as well to represent the remaining pins that are in there. So the next thing I'm going to do is obviously place the others. So simply, once again, place new device view. I can minimize it. And again, I'll just get the socket. You'll see now automatically when I place it, it won't actually let me place it outside the block. And at the same time, it won't let me place it in a block that doesn't belong. So the A3 will only let me place that X3 connector to that particular block. So there is a bit of logic in there that will stop you from making a mistake. That being said, if you had 5 or 6 connectors, you have the option obviously to place as many as you require for that particular schematic. And finally the ECU. Placing device view. I'll select my. So I can actually change it to be the default in the to make these the default, but I'm just doing it for this particular example. So for example, if I try to place there, you can see on the bottom left it says that it's invalid, and it says that the block symbol has to be placed on a block symbol view number 1 of device ECU. So it won't actually let me place in any of those. At the same time, if I hover out, it says can be placed inside the block symbol as well. So it's there's a bit of a failsafe there, which is fantastic. So when I've done so, I can connect in a few different ways. I can connect one by one, but that's going to be a bit tedious. It really depends on how, I guess, the logic is going to be in there. But I'm just going to use a few tools just to show you, I guess, how it can be quite easy. First thing I'll do is I'll just align these so they're a little bit better. Okay. So with that, there's a few automatic aligning tools. So I can auto connect horizontally, like so. I connect these ones horizontally. You'll see there it already calls up the X7 view 1, so it understands that that's the connector that's there, and you can see here it uses the mil symbol as standard that way. So it knows the connector is already there because we've already defined it in the previous view. It's just pulling it up as necessary. So at the same time, I can auto connect horizontally. I can also auto connect vertically. Let me align these again just to make life a little bit simpler. Okay, I've offset it so it's actually spliced it onto that point, but nonetheless it's probably not a bad example. So we can actually cross it over. You can see here with these symbols you've got the option of having the dot to represent a or you can have the offset line as well. It really depends on how you prefer your view to be. So after that, there's a few other tools. You can do a curve connection, which is not really necessary. You can do a point-to-point auto route. So if I want to say this particular connector is connected there, you'll find the path of least resistance isn't necessarily the neatest, but nonetheless, it's a pretty easy option. Once you get pretty full in your schematic, you will find a way around to route it. So then, but the one I'm going to use probably a bit more beneficial is a multi-connect tool, especially when these offset or these angled connections. If I pick up these, I select those, you can see here it's given me, it selected them all. And obviously I can go straight, which I don't necessarily need to, but what I want to do in this example is actually curve them. Now with that, you'll notice, for example, in this particular one, the leftmost at the top will be connected to this one. Now if I wanted to change that around, I wanted the leftmost to be connected to the bottommost of this X7 connector. I could simply hold shift and it'll flip them around like so. So it's pretty easy to connect a large series like as necessary anyways. So I can do the same for this particular one. Use the multi-connect, select a few of these and hold shift if need be, otherwise I can leave it, and then I can select the next remaining connectors, leaving a few in between if necessary. So you can fill them up pretty easily, pretty flexible. The good thing again is it's dynamic, so once I require, I can move it around. There is a bit of a restriction, and there are other algorithms that will stop you from changing your connections if necessary. But nonetheless, it gives you a bit of freedom to move things around. As you can see. So if you require more space and everything else, you can create it quite simply. As well as that, you can actually move these pins. So if I extend this block out for argument's sake, and I want to change these few, or these bottom few, I can simply move them down to more suitable position. So although they're the same block, I should remove that one too. Although they're the same connector, it keeps it still together and obviously understands it's the same one, but allows you to separate it so it actually fits a bit better in your schematic. So we'll let you define it a bit easier. So once you've done something like that, the benefit also becomes, if I go back to my schematic, if I pick a particular segment, I can go right click, I can go connection properties, and then I can go inside and check on the information. So at the moment it's blank for a particular reason. I've given the connection logic. What I want to do is actually give it some wire information. Now I could have done that as I was connecting it if I just ticked this button, but I'll show you how to do it separately. So for example, I can choose a wire type color. So for example, a TXL black red, gauge size, and then I can assign it to a particular wire cause. So I'll do these in black red. I'll just do orange, say 22 for these ones, and so these can be violet, and the remaining ones I'm just going to go black to keep it simple. Okay, cool. So pretty easily I've just added, so let's just give them a core number for each particular one. If I hover over it, we'll see that it will be a 20 gauge violet, and the wire name, signal name as well, which I can change if need be. So if I go back to my sheet now with my overview, I can click on anything and it will give me a couple things. So I can go segment diameter, and it'll tell me through that segment there are these particular cables and cores passing through, and obviously you can see the colors are there. At the same time, if I select this one, you'll see a difference. So it's got the black and the purple. So through any particular segment, it'll show me what's actually in there, which makes life pretty clear, just like this one as well. At the same time, I can go right click, connection properties, and through my individual cores, it'll actually tell me all the cores that pass through that segment, and obviously going from here to there. So at this point I can actually change them if need be. So I can define it from this view, what cores go where, and then at the same time, if I wanted to, I could change the wire information as far as outer diameter, gauge, color, etc. It's all pretty flexible to change. At the same time, there are a few attributes you can add if need be, but I'll just ignore that for this particular example. So it's pretty easy to define. You can actually start from a schematic and work to a topological view, or you can work from a topological, work to a schematic. You can even start from a harness drawing, work to a either of them as well. So what we're going to do now is go to my form board, which is basically just a harness sheet for a harness drawing, and I'm just going to replace the same ones as a say a realistic size. Well, not necessarily realistic. I can do it to scale, otherwise I can place it actually to a 1-to-1. So with the form board, for example, I'm just going to change my sheet size and choose one of these. I'm just going to choose this one. So this particular sheet is actually 2.5 meters by 1.25 meters. At the same time, I can scale it if need be. Obviously, it's going to be more than 2.5 meters. We do have very large sheets. If you've got a plotting machine, you can print 30, 40, 50 odd meters in one. So once you do draw a harness drawing, you can draw it to scale. So once you print it out, you can actually manufacture it to that particular drawing, which makes life a bit easier. But just for this example, I'm just going to scale it, say 1-to-2 just for now, and then I'll just create some dimensions as well. So I've got my new sheet open. So if I get those same, I guess I'm not going to use the blocks anymore. I'm just going to get those external connectors. So if I select these 4, I can go right click, place new device view, and a bit different, it's going to actually allow me to put some side views, and I want to put my, actually sorry, no, I'm just going to go place on form board, and it'll let me select the side view. So once I place it, for example with my first connector here, it also places a table automatically. So I'll just place them a bit all over the place, and then we can move them around as required. Excellent. So you can see now automatically I've got a dotted line. So this dotted line represents a logic that's going between. So obviously there's a signal going from this connector to that connector, that to that, this one to that one to that one. So if I zoom in now to my tables, you'll also notice a couple of things. The table automatically is going to, I guess there's a lot of different tables. So this particular one that I've created will actually tell me if it's a, in my description, and in my manufacturer as well, and it also will fill out my signal, my color, my size, and the destination of each particular one. I can add some notes if I want to a particular segment, be it an assembly instruction or something like that. And that's all dynamic. It's part of the table. It can be moved around. At the same time, there's different attributes you can add, and they'll call up automatically based on that particular connector. So if I check this connector, for example, device properties, there are a bunch of attributes that are automatically assigned to this particular component. But then at the same time, I can change that around. I can add more information, even if I wanted to add cost, lead time, material, anything like that. Some of the connectors already have them, but I can add that information if required. So you can call it up on the table as well if need be. At the same time, if I was actually starting from here, and I wanted to define a cable or a connection from here, even if I got a predetermined cable. So I bring up one of my cables in my database, and I'm just going to use a Carol cable, for example. So with these cables, there's a few different ones. I'm just going to choose a 22 gauge, one of these. Expand it out. You can see it's shielded and it's got 9 cores. So quite simply, if I go right now, if I just bring the cable over, I can go from a particular row, but at the same time, if I just want to fill up, instead of going for a particular row, if I just want to fill up the next available ones, I can click on the connector. Oops, I can click on the connector and I can go to another connector, say this one, and then I can click it there. So it'll actually fill up the next available ones in the table. And a couple of things, obviously any information as far as color goes in that particular harness will come in. So these ones are uncolored, but then we've got the black, white, black, orange, etc., and then the gauge, so and the destination, obviously. So they automatically gets filled, and then all that information is pretty dynamic. The good thing about that as well is once you create a cable, these are manufacturable cables. If you want to create your custom cable, for example, you can do so, and all your color, gauge, size, outer diameter, etc. will all be done in there pretty easily. So you have the option of either starting from a form board or a harness drawing. You can select your TXL red at 20 gauge and actually go from pin H in connector X5 to connector X8 pin A, for example, and you'll see there I'll fill up, and obviously the color, size, destination. So with that, at the moment I've just left my connectors blank. If I wanted to change them to a particular function, so for example, I think X5 was connected to ECU. So we've got X5 here connected to ECU, as you can see. So if I go back to my form board sheet, if I wanted just to change that to, I can call that ECU, rather ECU1. We already have a component called ECU, which is the block. So I'll just call it ECU1. So what that will do is I'll actually rename this particular component. You can see the ECU1, but at the same time every other sheet. So if I go back here to my ECU on the right, ECU1, and at the same time this particular one, ECU1. So it keeps the logic between one drawing and the other. So if I make a change to the name, it changes the name to all of them. So at the same time, the good thing about that is if I go to this particular connector, for example, the destination now says ECU1 connector H, so it'll define it that way. So you can actually add a fair bit more information as far as what's connected and how everything's labeled and everything else. It's going to make the design part pretty easy. So again, you can actually start from a harness drawing, work towards a schematic or a topological, or the other way around, back and forth pretty easily. So once I've done, I've just placed my connectors pretty simply. What I can do is I can start to draw a segment. If I can just press my connection tool, I'll just place a segment here, and then I will go find this one. I'll just do an angled connection to this one. Oops. So I might flip it first. Make sure I've got the right end. So the good thing about that as well is it automatically will rotate. So if I place a segment there, you'll see here that the connector has actually rotated. So once I do move it around, it rotates automatically based on that segment. So it keeps the views pretty neat. So I've got that one. I'll just connect this one again. Oops. So once again, you'll see it actually rotates pretty easily to show properly. So they can be changed around pretty easily, but it all depends on how you want it. So the next thing I want to do from here, I've added a bit of a structure, or I guess my segment breakouts and everything else. My breakout points, obviously the breakout points can be rather than just a T in the middle, we can change them as necessary. So what I'm going to do is I'm going to actually give a dimension to that. So at the same time, I can go segment diameter and actually tell me what goes where. You'll see here this particular cable, because it's shielded, it's separate, it's actually got the circle to represent that particular one. The other thing as well, it will tell me the minimum possible diameter for that particular segment with all those connections. So at the moment it's showing me a 13.4 mil diameter. So if all that is in there as tightly as possible, that's where it's going to be. So what I'm going to do is I'm going to select this segment, and I'm going to give it some diameter. So at the moment it's displaying at, acknowledging the scale, it's displaying at 13, say 1.36 meters. So if I want to change that, for example, to 1.4, there's two things I can do. I can actually click adjust segment and click OK. So what that's going to do is it's automatically going to change that particular segment into a solid green line. The solid green line means that the displayed length on the sheet is actually the true length. In this case, it's scaled to 1 to 4, I believe it was. But if it was a 1 to 1, it'd actually tell you that you know that that's the true size. So at the same time, if we've got a segment like this particular one, if I can select it and go my connection properties, it's showing me 450 mil on the page. So if, for example, that was going to be a 5 meter lead, I don't really want to draw 5 meters on the sheet, even if it is scaled, but I just want to show that this lead is here and it goes that way or whatever else. I can do so. So if I click OK now, it's going to stay in that red segment. So that red segment again is displaying that what the actual dimension of this is not really what's on this page. So if I was to measure that using my measure tool, and simply assuming I've got the settings correct, yep. If I just measure it from this particular point up to here, and I can place the measurement here, it's currently showing me what's on the page. Apologies, I've selected something wrong. Excellent. So select from this particular connector to my center point. Okay, so you see here it's showing me that it's got that 5,000 millimeters. I can actually change that as well. I can get rid of my precision. I can put a suffix of millimeters, etc. I can change an offset. I can change the size, etc. The arrows as well. I can do the same thing. So there's a few different options, and I can do that standard. So every time I do a dimension, it'll come automatically. So that's showing me that it's a 5 meter dimension. Now, if I move things around, so if I move this here, for example, now, it's still going to be 5 meters. It's going to show me exactly what's the manufacturing length, not necessarily the what's displayed on the page. So that red dot is representing that there's a difference between the manufacturing length and the displayed length. However, this dimension is always going to be attached to that manufacturing length. So again, if I highlight over it, it'll actually tell me how many cores are in that particular one and what the core name as well is. So I can add a dimension to all of them. So once I've done that, I might want to add cable protection, which is pretty straightforward as well. I can find my heat shrink cable protection, say I don't know, 1/4 inch, for example. I might get one of these. So DR25 or the high temp, which is the RW200. So with these as well, there's a bit more information. I can go to my component properties and it'll tell me the post pre-recovery. It's also got a hyperlink, tube diameter, and material as well. So I'm just going to get the 1/2 inch, which technically probably isn't big enough. But nonetheless, I'm just going to place on the segment. So I can select the segment, and you'll see here it attaches like so. So the good thing about that as well is it's dynamic. So even though I've done that, if I move these around, you can see it becomes attached. It won't actually, it's attached to it. It understands the dimensional characteristics as well. But it won't move around. So once I attach it to a segment, it's attached to the line. You can move things around if you change your mind or if you need to do some sort of movement or whatever else, you can do so. I'm just going to place a 3/4 inch on this segment. Now with this as well, you can you can actually create an algorithm or a script rather that will actually select the correct size segment for you. So once I've done that as well, there's also cable protection, boots, etc. If I've got a boot, if I want just a straight boot, non-lipped straight boot, I believe this might be the size. I can place it over this particular connector like so, and then once again it becomes dynamic. So if you move it around, it's attached still, so it allows you that flexibility. And at the same time, this particular boot, I can go right click, simple properties, device properties, and I can check my post, my heat post and pre as well. So it'll tell me, obviously it's a 20.6 pre-recovery internal diameter, and then it can shrink up to 6.6 millimeters. So I can use that to choose. These particular ones just have the description pretty generic, but you can use it more defined if necessary. So you can put your T connections, everything else you might want to do. At the same time, you can actually put some labels if required. Put this one just for argument's sake. So if you want to label at near the end of the segment. So these particular symbols, they're just created dynamically, so we can actually change the size to represent as required. It's just going to be a pretty simple label. Otherwise, you can actually do a straightforward. So this one, I can go in my device properties and I can change my label text to be connector 1. My connector 1 have the signal name and tag color, for example, if I wanted to. So once I fill that in, it'll be attached as required. And once again, they're all dynamic. So if I move this connector around, it will stay with that as well. So you can populate as much information as you want. There's cable mounts, you know, all amount of cable protections in there, be it corrugated tube or something like that. Labels, tape, etc. There's a few miscellaneous type things. It can all be added pretty easily. So you can see from a harness drawing to a schematic to a topological drawing, you can do the same thing, multiple views pretty easily. It's actually representing the same information, just in different characteristics. So again, I can go to my connection properties, and for each particular wire, I can actually see what the information is. Now, in this particular example, you can actually see here, so because I've defined that dimension in this one, I've only defined one dimension, it's actually telling me it's 5 meter length. So with the different ones, this one I did 1.4, so I'll actually know the length once I fill it in, what the length from start to finish is. Now there is more to it, and I can explain in a second, but you can actually change a bit of information. So these wires aren't really populated. They've got a resistance per millimeter squared per meter, and at the same time, some of them actually will have wire weight, so you can work out your weight from there as well. So if not, you can populate it, but nonetheless, once again, you've got your information, you've got your cable, your shielding and everything else in there. So all your information's there, pretty easy, pretty quick. If you make a change in one, it's going to follow through and keep in the next one. So you have the different views, the different instances of the same drawing, and then you can extrapolate all the information. So from that, for example, I can get a connection report. I can do it in a sheet. At the same time, I can do it in the bill of materials, in a Excel. And I'll just do this one just to show you. So with that as well, the software will allow you to embed drawings, projects, or any other sort of data or files. That includes PDFs, Excel spreadsheets, etc. So it will let you import any other sort of drawing that you might need into this particular one, so you can keep everything in a central location. So again, be it a insert a file or an object. So the file, there's many different file types. So whether you have an image, a PDF, a script, an Excel spreadsheet, a Word document, you can have anything you need. So you can see here by my my table at the moment, like I said, I didn't populate all the lengths, but you can see my signals. If there was one assigned, automatically it gets assigned for most of them, from pin to pin, and then my wire core number, type, and then the color gauge, and then the dimension in that particular one. So you can see that gets populated automatically. That way you can use this one for your assembly instructions and everything else. If it's part of a cable, the cable gets tagged together, and the cable name itself can be changed as well. So that cable, you can see CBL1, which represents those. You see here, I can expand that out. It'll tell me ECU1 to X6, and then obviously K to D, etc. If I was to change this KBL1 to give it a designation name, cable designation 1, whatever you might want to have it, it will change the cable name there, and at the same time, it'll keep in the different views. So if I go back to my form board sheet, for argument's sake, you'll see there the cable designation 1 gets changed, so it keeps full consistency. So at the same time, all my reports, everything else will have the same thing. Thanks for watching. Hope that gives you a bit of an idea how E3 can aid your vehicle design from start to finish, whether it's a small stage or the full design process. There's definitely consistency of design and taking advantage of the database and the way the components are linked. You can definitely do things once instead of repeating the same action multiple times. Thank you. Once I've created my block diagram using Zuken E3.Series, and I have created somewhat of an overview. At the moment, I've just got 4 different locations. One of the locations, for example, is the turret that I've done. Now, this particular location could represent multiple different subsystems. So I can actually expand further on the overview and go through there. So at the moment, I've just called this block turret. I can go into this particular block and change it from a regular block into hierarchical block, and within that I can actually the first thing you'll notice is the block symbol displays different. Instead of the black border, it goes into a brown border, and then I can go into this particular one like so, into hierarchy, and so now this full sheet is actually representative of what goes inside that block. So if I rename this one, for example, into turret, to identify, and at the same time, if I wanted to, I can import the same DWG. Might even expand it a bit bigger, just for argument's sake. So once I've done so, I can get rid of the unwanted graphics. And I might even just leave turret, or a large portion of the turret. So I can actually, at the same time, I can group an object, so it moves in a group, and expand it out as required, so I can make this a little bit more visible. Once I've placed my graphic, I can further go through this X3 connector, for example, which represents that particular one. So this, if I click on my overview, you'll see that X3 is actually that connector that sits outside of the block. So I can go and place inside hierarchy. I'll just use the standard mill receptacle symbol. So once I place it into my project, you'll realize here that I've got each signal is already in there. So if I was to connect new cables within that, each time I create something new, it will automatically place a new signal, like so. So the 1, 2, 3, 1, 2, 4, 1, 2, 5, if I go back to my main overview in here, so in this particular connector, for example, it will now have those 1, 2, 3, 1, 2, 4 and 1, 2, 5 symbols. So any logic I have within this particular hierarchy, I can have a subset of other systems and circuits and everything else. the signal logic will transfer from that to that. So for example, if you had a tail bar assembly, within the tail bar assembly you might have each particular light, your indicators, etc. Any logic of the circuitry that sits inside that tail bar gets transferred obviously to the ECU, etc., or any other controls. Whatever logic goes there is there, so any signal is fully trackable. So you can actually go through and open up a signal tree. So each particular signal, so for example the 125, I can go through and then I can track it on this view. I can track it on the hierarchical block. At the same time, if I go to my overview, my harness drawing, or even my schematic drawing, it'll tell me exactly which pin goes through that particular signal. So if I was to connect this one to something else, it keeps the logic. Oops. If I connect it to a vacant one, it would, oops, where are we? It keeps the logic through each particular signal, which makes that pretty easy. So there's full trackability. These signal names can be renamed pretty simply. So for example, signal 30, if that was, I don't know, swivel, or even power, we call 31 negative, which obviously there's going to be a lot of negative in a lot of the systems. They're normally be bridged or spliced rather. In my signal tree I can go through and locate this negative. I can open it up and then I can go between the different the harness, the overview, like so. So through the different systems. So the full trackability from one to the other. Every time I make a change on one particular signal, it comes through and it keeps on the other one. So power negative and the same on this X6 connector, and obviously the X3 goes through. So from that block through the mating connector, and then through the actual opposite end of that harness, and then onto the A2 block and then the mating connector once again. So like I said, you can keep full trackability from one point to another. If you've got a complex system, a complex harness, you can track it pretty easily. So